All right.
Hello. All right.
So we're going to state the domain and range for each graph. Tell if it is a function, yes or no. If the graph is a function, state whether it's discrete, continuous, or neither. I'm going to start with discrete, continuous, or neither because we haven't really defined that. Discrete graphs are graphs that have a bunch of little tiny pieces like this. You have separate points. So this graph right here, I'm going to write to the side that this is a discrete graph. It's like every point is its own little secret. Isn't connected to anything else. I'm just trying to link this to something that you would know. Goes with the word discrete. Continuous means that it's all connected.
I have an example. I'm probably not allowed to say.
Okay, we're recording. All right, so we have done domain and range with these kinds of graphs before. So remember that if we go through and find all of these points, the domain and range is easy. So this point down here is -3, -4. This one up here is -2, 5. This one right here is 1, 3, 1, -2, and this is 4, 0. So if you remember from previous lessons on domain and range, the domain is all of the x's. And we usually put it in little curly brackets. If you can't make the brackets, just put it on the line. So all of my x values would be -3, -2, 1, and 4. Now we used 1 twice. You only list it once in the domain. The range is all of your y values. I like to go bottom to top just to make sure I don't miss anything. So the range is -4, -2, 0, 3, and 5. So none of those repeated. And then it asks if it's a function. So do you guys remember how to tell if it's a function?
Oh, the vertical
yes.
line test.
Vertical line test. So does this pass the vertical line test?
No.
No, because these 2 points are right above each other. And we talked about before, when you have x values repeating with different y's, that makes it not a function. So we're going to say no on the line with function. So with this discrete graph, that's not that bad.
Wait, so it can. Okay. So if it is a function, state if it's discrete, continuous, or neither. So is it discrete? Even
So I guess if it's not a function, we didn't have to do this part.
I just didn't know.
So on the assignment, if we write no there, then skip the discrete, continuous. I think if it's not a function, they don't worry about that so much. But discrete graphs do look like that, so that's a good question. Okay, so let's start with that on number 2, since that determines, would number 2 pass the vertical line test?
No.
No, so it's not a function. So according to these directions, then I do not have to state discrete, continuous, or neither. We can just skip that part. You can do the domain and range for this relation. So for this, it's going to be a little bit different. Your domain is a range of numbers that goes from -3 over to 3. So, and those points are included. So for the domain, we're going to use our interval notation. My x values go from -3 to 3. So you can see that that's the leftmost point and the rightmost point, and everything in between is filled. You can look at the top part or the bottom part to see that.
Crazy.
And then the range would be how far it goes from the bottom to the top. So it goes from -4 to 3. So I would just go -4 to 3. Does that make sense?
Yeah.
And I'm using square brackets because those points are filled in. They do count. It is not a function. It does not pass the vertical line test. Okay, so moving this over to number 3. Let's start with, does this pass the vertical line test?
Yes.
Yes. Now when we're talking about discrete versus continuous, a continuous graph is usually defined by I can take my pencil and everything's connected and I can go all the way across without picking up my pencil. So the only thing that might be weird is this little point here, but I believe that this is continuous because I could draw this segment, and this without picking up my pencil. It's all connected. It's continuous. It's unbroken. So I would say that this is continuous. It does have a break on the end over here, but we're more like looking for breaks in the middle that would make it not continuous. All right, so the domain, how far left does the function go?
-4.
Negative 4. Is that point included? No. So we show that with a parentheses, negative 4. And then what happens on the right end?
It just keeps on going.
It keeps on going. So what do we do with that?
Infinity.
To infinity and beyond. And infinity always gets a parentheses because it's not really a stopping point. Okay, the range, we're going bottom to top. So what's my lowest y value? 1. And is 1 included? Yes. If there are any points at 1 that are included, then you're going to use a square bracket. And then how high does it go? Infinity, because in this end. Now this end, it goes to 3. If I look over here, it's going forever. So I do have to use infinity. It is a little weird. You have to look bottom to top, all parts of the graph. Okay? So that's number 3. All right, number 4, let's start with, is it a function? No, it's a circle. So I don't have to say discrete or continuous or whatever. So for the domain, what would you say? Negative 2 to 2. And those points are filled in. They're included. So from negative 2 to 2, that's basically how far left to how far right we're going. And then what would you say for the range? 0 to 4. So we're just going bottom to top. You do have to go left to right. You do have to go bottom to top. So I'll just put these little arrows to remind you that that's the order you have to go in. You don't get a choice. You can't say from 4 to 0. They don't consider that correct. In my brain, it makes sense, but sometimes that's different. Okay, on number 5, is this a function? Yes, this is the first function we really ever looked at. It's lines. Get all like emotional. Aww, we've been doing that since middle school. All right, so the domain is how far left to how far right. What are you thinking on that?
Infinity.
So negative infinity to positive infinity. Use parentheses on that. And the range, if we go bottom to top, is going to look the same way. So if you have a line, as long as it's not vertical or horizontal, if it's like a slanty line of any kind, this is what your domain and range will look for a linear function, for a line. Okay, so mixing it up a little bit. This is an absolute value function. When we're doing domain, we go, actually, I guess I just told you it was a function, so we'll say yes there. It does pass the vertical line test. When we're looking at domain, that's from left to right. So what do you guys think? Negative infinity to infinity. It goes forever to the left, forever to the right. There's no breaks in the middle. Now when we do range, it's not negative infinity to infinity. Where does it start?
5.
So negative 5 to infinity. So is it included? Yes. So the negative 5 is included. Infinity is not a number, so they don't consider that included. So it goes from negative 5, goes up forever to infinity. So we're just going bottom to top. So domain is left to right, range is bottom to top. Okay, let's look at number 7. Is this a function?
No. Why did I say that?
Does not pass the vertical line test. Any vertical line over here would cross twice. So I don't have to, oh, you know what I forgot to do on the last 2? Let's back up. On 5 and 6, these are both continuous. They're continuous because you could graph them. We're not talking the arrows on the end, just the main part of the graph is all connected. You can graph it without lifting up your pencil. I can make that whole V shape or this whole line without picking up my pencil. I'm not leaving any weird breaks in the middle. All right, so let's look at number 7. So we said, no, it's not a function, so I don't have to do discrete or continuous. What would be the domain?
0 to infinity.
0 to infinity. Am I including 0?
Yes.
Yes, so I'm going to use a square bracket. So 0 to infinity. So from left to right, it starts at 0, goes forever to infinity and beyond. Okay, so for the range, we go bottom to the top. So what's the story there?
Infinity to infinity.
Negative infinity to positive infinity. Don't forget to put the negative on the first one because it's forever in the down direction to forever in the up direction. Okay, number 8 is a little bit weird. First of all, is it a function?
No.
No, it fails the vertical line test right here. There's just one spot where those points are. If I was doing the domain on this, it goes forever to the left, forever to the right, and technically it doesn't skip negative 1. It's on there twice. So we could say negative infinity to infinity. My range is very limited, though. I only have 1 and 3. So what they often will do with this is do the little curly brackets and just say 1 and 3, and those are the only numbers. So not parentheses, not brackets, not interval notation. So that's a little weird. I also have seen weird things where they will actually put 1 to 1 and unite it with 3 to 3. That's kind of awkward. So usually they'll just go back to normal set notation like we did on number 1 and just say 1 and 3, and that's
How do you
it.
do a bracket?
So with the curly brackets, there's different ways. You can do like 3 little loops like this. This is how I make it fancy, but I've had a lot of time to practice. So some people do like a little curved part and then a sharp part and a curved part. So any of those, just make sure it doesn't look like a parentheses. So make sure it doesn't look like parentheses or square brackets. That's the main thing. Make it look like it has bumps in it. And then realize in the real world people type these symbols so you don't have to write them. All right, so number 9. Is number 9 a function? Yes. It is not continuous. It's not really discrete either. So I'm going to say it's neither. It's not continuous because it has this hole in the middle where I'd have to pick up my pencil. I have like this section and that section that are sort of separate. There's a hole in the middle. There's a hole in the middle. It's not continuous. The domain is a little interesting on this. You have to do it in pieces because there's a break. So I'll go from left to right for the first piece. So negative infinity up to negative 3. So negative infinity to negative 3 using parentheses. And then I go from negative 3 to 2. Make sure you're using x values. So we did use negative 3 twice, and because we have those parentheses, we know that that was a hole. Does that make sense? So negative infinity to negative 3 and negative 3 to 2. On the domain, make sure you're using just x numbers. It's really easy to forget and use the 1 from the y-axis. So just be careful. Anything on the y-axis is for the range. So on the range, we go bottom to the top. This point's not included, but there are lots of other points here at negative 2. So we'll say that negative 2 is included somewhere. And then if it didn't have this arrow, we'd say it goes to 1, but it actually goes up forever on this end. So we're going to say it goes for forever. So that's it.